Hi, my name is Henry Michael Smentek. I am a 7th grader at Dakota Meadows Middle School, and my project is how does temperature affect a football? My observation was that Tom Brady deflated footballs to gain an advantage, and cold also causes footballs to deflate. Therefore, I wondered whether temperature would affect how far a football flies. My hypothesis was that a cold football will fly further because the temperature makes the ball flat. So my procedure was I got 3 Wilson official size MVP footballs. All were in the same batch. They were all pumped up to the same PSI. One football was warmed to 87 degrees. One was cooled to the temperature of 42 degrees. And then one stayed at room temperature, 75 degrees. Then the temperature was measured with a Ryobi non-contact infrared thermometer. I went to TCO Orthopedic Stadium in Eagan, Minnesota, where the Minnesota Vikings staff, Adam Gruen, assistant equipment manager, helped me with the experiment. Mr. Gruen operated the Jugs football throwing machine, which threw the football at the same speed and angle every time. The machine was set to mimic a short NFL pass, approximately 20 yards. Each ball was ran 3 times. As we were indoors, there were no weather conditions that could alter the ball's flight. The manipulated variables were the temperature of footballs, which affected the pressure of the football. The cold ball was noticeably flatter than the other two. The controlled variables were that the footballs were all the same make and model, inflated to the same pressure. The field was indoors with no wind, room temperature of 75 degrees, and all balls were thrown by the Jugs machine set at the same speed and angle. My data was that the Jugs machine was placed at the goal line, and the line markers on the field were just used to measure how far the football flew. I marked where each ball hit on the field in order to measure the distance flown. The distance the ball traveled, the cold football for football A traveled 20 yards, the cold football for football B traveled 20 and a half yards, and the cold football for football C flew 20 yards. So that makes an average of 20 and 1/10 of a yard. And football A at room temp, 75 degrees, went 21 yards. Football B at room temp went 20 and a half yards. And football C at room temp went 21 yards, which means an average of 20 and 8/10 yards per football. Football A at warm 87 degrees went 21 yards. Football B at warm went 21 yards. And football C at warm went 21 yards, which means an average of 21 yards. And then my conclusion was that the warmer footballs flew further than the cold ones, and room temperature footballs. The football being cold and flatter did not help the football go further. Follow-up questions. Would the results have been the same with a different setting on the Jugs machine, punt, long pass, etc.? Would the results be the same in different weather conditions? Is a cold, flatter football easier to grip and therefore throw? Would the results change if the ball is kicked, not thrown? I only had limited access to the Jugs machine, so we could not do all the trials. I would have liked to, though. And a special thanks to Les Pico, Adam Gruen, and Rich Molitor, and my dad for getting me to Eagan, Minnesota, to the training camp. Thank you for your time.